What I'm going to do is plug this in and turn it on, and I have a tick tracer here. I just wanted to show you something, because it's one of the things that I learned even when building this unit down in my cellar. What happens when you have an energized system, it puts out a field. We're going to be able to detect with this particular tick tracer just how much of a field this puts out. You hold on to this, okay? Now I'm going to put my rubber gloves on, but I'm not going to give you any gloves. I'm going to give you that tester, so you know how close you can get.
You'll make them go off?
What I'm going to do is I'm going to curl his hair. He and I probably go to the same barber, so I tell you the same kind of haircut we got here. But anyhow, what I'm going to do, I'm going to take and plug this little guy in, and then we're going to show you just how much of the field this little guy puts out. Back up a little bit, my man. Get out front here, Bobby. Get out there about maybe 6-7 feet. Now, put it out, walk just. That's the field. That's the same. That energy is now enveloping anything in this particular area. Okay? Exactly like so. Anything in that area that's conductive will accept that energy. We call it static. Static can kill. I have to be very careful when you move around here. One of the things that happens, you can shut it off, Bob. If you don't like creepy crawlers, you don't want to be a power lineman. Because what happens is, you know, you feel like you got those little creepy crawlers. Wherever you got hair in your body, it moves a little bit. If you're sweating, you can actually feel it. So it's not a really good feeling, but after a while, you get used to it. Especially since I started working with it in the 50s. So I'm pretty well used to it by this time. But is it hot? Let me tell you something. It's hot all right. What I'm going to do is take this piece of wood. Now many of us would say, is wood an insulator?
Well, wood's not conductive, right?
Is wood a conductor?
Yes, it's moisture.
Actually, what I'm going to do, I'm going to put this down, and what I'll do is I'll use something else. Because I know we know whether it's a conductor or not. Put that rod out there. Need that rod. No. This one here. Hold this wood.
You can already see it smoking.
Just to give you an idea, what you're going to be able to do is see 15,000 volts. I'm going to put it down, get close, and strike it on. That's 15,000 volts. Now, actually what happens is, you notice something happening here?
Yep.
What's happening there? You see this little thing that's on? What happens is anything hanging on that line, okay, is subjected to that electrical current that's up there, that field. And what's happening, it's moving. It actually moved down and made contact with that crane boom. Now all of a sudden what happens here, oh heck, we're below the wires, we don't have to worry. Well guess what, did you see where it made contact? It made contact right here at the top of the boom. We didn't see that little piece of wire hanging off. We didn't see that piece of insulation. We didn't see that piece of string hanging off, but it can take and transmit current. But anyhow, it's hot all right. We'll put this down and now create the arc. Now, one of the things that we get in the safety department is we always sometimes have to take and investigate electrical contact accidents. And we always get this thing, hey, we saw the electricity jump out and get them. Wrong. They didn't see the actual contact. You see, electricity will not jump that far. It'll jump about 1/4 of an inch for each 10,000 volts. So here, if this is 15 kV, it might jump 3/8 of an inch, but it's like your girlfriend. Once it gets a hold of you, like to hug you to death. Okay? Here's what happens. Look how close we get. 3/8 of an inch, it makes its arc, but now I have to create resistance through distance to break that. The air normally around us is non-conductive. Right here I have an opening about 1.5 inches, 2 inches. What I'll do is create an arc. And that arc is not straight across. Basically what I've done is I've ionized the air through creating that arc. It usually takes anything over 600 volts to sustain that arc. Anything below the arc will not be sustained. But anyhow, you'll notice that the arc is not straight across. There's an apex to it. And the reason being is now what's happening, the energy is following the contaminated air, the gases. Now to get rid of that, what I can do is blow it out. Don't try that out in the field. Unless you want hot lips, I'll tell you. He'll get you, I guarantee you. I know where my money is. But what happens is, okay, you can see that the air is normally non-conductive. That's why distance becomes such an important part of our business as we talk about electricity. Now we know that metal will short out electrical systems, but how about wood? Years ago, hot sticks were made of wood, but they were treated. I broke this off yesterday and had it sit in the back of my truck pretty warm. But the thing about it is it's relatively green. So we have to understand that it will conduct. We saw what the metal will do. Let's see what this wood will do. Put that across there. And you can see that wood basically is almost as good as that piece of metal. And you'll notice that it will conduct. Now, the more it burns, being a Class A material, the better conductor it becomes. You see that? Because now what happens, Class A material turns into what when it burns? Carbon. So the longer we hold it on there, the worse it gets. How many of us have sat home and the lights go blinking down, and they go back up again? Two things. That's either a lazy squirrel that didn't lift his tail up, or it's a tree branch that's hitting that wire. Now what will happen is if it burns itself clear, you've got it made. But if it don't, then all of a sudden that's where the lights go out. Because now what happens, it's turned into carbon. The resistance is such that now you have a particular short in the circuit and one of the protective devices that actually worked. Now, to help me out here today, I knew that y'all would not volunteer, so I brought my own little volunteers. These are all little hot dog people. We got them in buckets, we got them in trees, we got them over here working with a loader, we got them down here. Up here we're working with the boom. We got them up on scaffolds. We got them over here in the pool. Now what I'm going to do is I'm going to energize our little friend over here. He never realized it. He said, oh heck, there's a wire in the pool. Let me see if it's hot all right. I'll stick my hand down in there to see if it's energized. Well, now you can see the energy. He's not touching the wire. Basically what happens is our little friend is only touching the water. The water becomes conductive. And now that energy radiates out, and pretty soon what happens is we have a fatality. The other thing that happens is that if that radiates far enough, how many of us have talked about swimming pools at home, especially down the shore? Stray energy, very serious issue. One of the reasons why grounding and ground particular mats and ground grid systems are so often important. What we do have here is a tree that's fallen down, and what I do is I have maybe a utility worker here from the town, from the DPW, guy with the white hard hat. He goes out to get rid of that tree to cause and get the traffic moving. So he calls back and says, hey boss, got a problem. Get a hold of PS or Jersey Central Atlantic Electric. We got a tree down across the road and there's a wire in it. What we do? Well, stay there and wait for the power company. I'll give them a call. So they wait for the power company. He decides to open up a pack of smokes and go over and sit on a guardrail. Not realizing that the energy that's in that tree is energizing the guardrail also, and our little friend over here, okay, just like that, he doesn't have to light it up, we do it for him for nothing. And look at that tester. You see that tester? That tester was activated. This cable is made out of a non-conductive material, but we still have a gradient situation. Watch what happens. That tester is not really touching that tree. But what I can do, it'll actually take and pick up the field also. What I'm going to do is touch the tree and watch the tester. That's the gradient. Remember what he talked about? Remember when Dennis talked about the gradient, the step potential? That's why I said, if you're ever in a predicament and you suspect that there's energy, whether it's direct buried or whether it's a fallen wire, shuffle your feet, never take a step. The longer the step, the more difference in potential, the more current will flow. Always shuffle off. That's our gradient situation. Booms and booms, boom trucks. In this case, we've got a boom. It's lower than the wires. But you have to understand that the load is also part of the particular setup, that unit. And now those distances